Okay, so let's begin with question 1. Now, question 1 is asking us to find x given that 2x minus 3 equals x plus 5. Now, the only difference here between what we're usually accustomed to seeing and this is that there's a variable on both sides of the equation. And to do this, to solve these kinds of questions, all we have to do is get all the x terms on one side of the equation. So I'll show you how to do that here. So 2x minus 3 equals x plus 5. First, let's subtract the x's from both sides. So we're left with x minus 3 equals 5. And now this should be something that we're used to seeing. So now we just add the 3 on both sides to get x by itself, and we get x equals 8. And that's the final answer. Alright, now let's go on to number 2. Now number 2 is stating that 2/3 x minus 5 is equal to 1/3 x plus 4, and they're asking us to solve for x. Now this is going to use the same steps that we used for the previous question. So first, remember, we have to get all the x terms on one side of the equation. Now to do this, we'll just subtract the third x from both sides, and we get 1/3 x minus 5 equals 4. Now I'll just add the 5 to get the x by itself, and I get 1/3 x equals 9. Now the final step is just to divide by 1/3 on both sides. So divided by 1/3, divided by 1/3, which is going to give us x equals 9 divided by 1/3. And 9 divided by 1/3 is the same as 9 times 3 because of keep flip flip, and that gives us 27. So our final answer is x equals 27. Alright, now let's go on to some questions dealing with analyzing the number of solutions to a linear equation. So here we're given 50x plus 40 minus 3x is equal to 35x plus 40 plus 12x. Now here what we want to do is first we want to start by combining like terms, which are 50x and negative 3x, giving us 47x. And the 40 we can't combine with anything, so we're just going to leave it as it is. And then we're going to do the same thing here, 35x and 12x. They combine to get 47x as well. And then the 40 again, we're just going to leave it as it is. So here we're given 47x plus 40 equals 47x plus 40. Now as you notice, both the left and the right side are the exact same, meaning this is going to have infinitely many solutions. Now why this is true is because think of any number for x. Any number you plug in there is going to result in both the left and the right side being equal. For example, if we said x was equal to 1, we do 47 plus 40, and that gives us 87. And that's the same on the right side as well. And this is true for any number of x, and that's why our answer is infinitely many solutions. Alright, now let's go on to another question dealing with the same concept. So we're given 30x plus 30 is equal to 12x plus 24 plus 18x. And we can combine 12x and 18x here because they're like terms, and that will give us 30x. And then the 24 will leave as it is. So now we're given 30x plus 30 equals 30x plus 24. Now let's think about this as lines on a graph, right? 30x plus 30 is going to look something like that. And we'll say it crosses the y-axis at 0, 30. And 30x plus 24 is going to look something like this. Or, sorry, more like that. And we'll say it crosses here at 0, 24. Right? Now, if we notice, these lines are parallel, meaning they're never going to cross. They'll keep going straight, and they'll never ever cross. So they can't ever have a solution. So this would be no solution. Okay, now let's go on to some questions dealing with multi-step inequalities. So here we're given 7x plus 3 is greater than or equal to 2x plus 3. Now how we would solve this is first, just as before, we would first get all the x terms together. So to do this, I'll just subtract 2x on both sides. And I'm left with 5x plus 3 is greater than or equal to 3. Now I'm just going to subtract 3 from both sides. And we're left with 5x is greater than or equal to 0. And now I'll divide by 5, and we're left with x is greater than or equal to 0. And that will be our answer. Okay, now let's go on to another question dealing with the same concept. So here we're given 3x plus 4 is greater than or equal to 9x plus 16. So first I'll subtract out 3x, right, from both sides, giving us 4 is greater than or equal to 6x plus 16. Then I'll subtract 16 from both sides, leaving us with negative 12 is greater than or equal to 6x. Now we'll divide by 6, and we're left with negative 2 is greater than or equal to x. So x is less than or equal to negative 2. And that is our final answer. Okay, now let's go on to another question dealing with the same concept. So here we have to solve for x, and we're given y times, in parentheses, x plus 3 equals 3z plus x. So first let's begin by getting all the x terms in one part of the equation. So I'll start by subtracting x from both sides, and we're given y times, in parentheses, x plus 3 minus x equals 3z. Now I'll just simply distribute out the y, and I'm left with yx plus 3y minus x equals 3z. Now 3y doesn't contain an x, so I'll just simply subtract it to the other side, and I'm left with yx minus x equals 3z minus 3y. And from here, we'll simply factor out the x to get it by itself, and if we factor out the x, we're left with x times y minus 1, because yx divided by x is just y, and negative x divided by x is negative 1, and y is equal to 3z minus 3y. Now we'll simply divide out y minus 1 on both sides, and we're left with x equals 3z minus 3y divided by y minus 1, and that is going to be our final answer. Alright, now let's go on to questions dealing with compound inequalities. So here we're given 2x plus 3 is greater than 13 and 3x plus 5 is greater than 14. So to begin, we'll just forget about the and solve these inequalities alone. So 2x plus 3 is greater than 13. First we'll subtract out 3, and we're given 2x is greater than 10. Now we'll divide by 2 on both sides, and we're left with x is greater than 5. And now let's do the other inequality. So 3x plus 5 is greater than 14. First we'll subtract the 5 out, and we're given 3x is greater than 9. Then divide by 3 on both sides, and we're given x is greater than 3. So now we're given both of these inequalities. X is greater than 3 and x is x is greater than 5. And when we're given and, this means that whatever answer we get, it has to be true for both of the inequalities. Now, our answer can't be x is greater than 3 because that is not true for this, because in this case, it has to be x is greater than 5. So a place where both of these match up is going to be x is greater than 5. Because this is true both for this, for 3x plus 5 is greater than 14, and 2x plus 3 is greater than 13. Because both of these equations or inequalities will be true when x is greater than 5. And another way to think about it is through a number line. So let's say we have a number line and our answer here is 3 and here is 5, right? So let's use a highlighter, and everything past 3 and everything past 5 is going to look like that. So this interlap right here, that's our possible answers, because that matches up for both of the inequalities. So that is why our answer is going to be x is greater than 5. Okay, now let's go on to the last question. We're given negative 14x plus 3 is greater than 31, or 9x plus 5 is greater than negative 22. So first let's just begin by solving these individually. So negative 14x plus 3 is greater than 31 is going to be the same as negative 14x. So subtract 3 from both sides is greater than 28. And now we'll divide by negative 14 on both sides. And we're given x is less than negative 2. Now why the inequality sign flips from here to there is because whenever we divide out a negative number, we have to flip the inequality sign. Now let's go on to this, the next inequality, which is 9x plus 5 is greater than negative 22. First we'll subtract 5, so we're given 9x is greater than negative 27, and now we'll divide by 9, and we're left with x is greater than negative 3. Now what we want to do here is, again, we'll just draw the number line, and our first answer is x is less than negative 2. So if that's negative 2, all values to the left of that is going to be right. And here it's going to be x is greater than negative 3. So if this is negative 3, all the values here are going to make this one true. But notice how we're given or. So as long as one of these inequalities is true, we're good. So for this, we could either choose x is less than negative 2 or x is greater than negative 3. And both of these would be absolutely right.